All right, I'm back with another section for Unit 2, and this one is about the Pythagorean Theorem. So that 8.2 references the section that it is in your textbook. So if you want more information, you can check that PDF of the textbook or your hard copy. So the Pythagorean Theorem should be something that you're really, really comfortable with. And remember, the Pythagorean Theorem deals with right triangles only, and a leg, another leg, and the hypotenuse. Remember, the hypotenuse is always going to be the longest side, and it's always going to be the side that's opposite the right angle. So remember, in the Pythagorean theorem, a squared plus b squared equals c squared. You should feel good about that. All right, here we go. I want you to pause the video, and I want you to solve for x, y, and z. Okay, we're back. So on the left-hand side, this one is super easy. Here we go. So we get 2 squared plus 3 squared equals x squared. Solve, solve, and you get x equals the square root of 13. All right, the second one for y is a little bit more challenging because that is not your hypotenuse. So you just have a squared plus b squared equals c squared, but this case, we've got our b and our c. And then you solve, and you get 2 root 5. And then our last one, this one's kind of exciting. So you get z squared plus z squared equals 4 squared. And so then solve, and you get z equals 2 root 2. Hopefully you felt good about that. Moving on. So now I want you to pause the video, and I want you to find the hypotenuse for each one of these triangles. All right, we're back. So hopefully you figured out that these are all called Pythagorean triples. So the most basic one, and that we'll see all the time, is 3, 4, 5. And also what's important is that not only is 3, 4, 5 a Pythagorean triple, but any multiple of 3, 4, 5. So you could get a 6, 8, 10 as a Pythagorean triple, right? Or you can multiply everything by 3 or multiply everything by 4. And same thing for 5, 12, 13, 8, 15, 17, and 7, 24, 25. These are the big ones that we're going to be using and recognizing a lot. Now, this is just a time saver. So if you are looking at like this problem, for example, and you're trying to figure out what the hypotenuse is, you might forget the 8, 15, 17 relationship. And that is totally fine. If you should do the Pythagorean theorem out and figure out that this guy is 17, that is okay. But you're going to be like, oh, it's a Pythagorean triple. Whoops, I just, wasted like 2 minutes of my life. But that's okay. All right. So a rhombus is involved in our work with the Pythagorean theorem because there are right triangles within a rhombus. So this is an important thing about a rhombus. Now remember, a rhombus is, I like to call it a sad square. So it is a square, a quadrilateral, who all 4 sides are congruent to each other, but the angles are not necessarily 90 degrees the way they are in a square. So an important thing about a rhombus is, we talked the other day about the diagonals. So the diagonals of a rhombus not only bisect each other, but they also meet at right angles. So within a rhombus, I get 4 right triangles. That's super important as we move on to this problem. I want you to pause the video and try and solve it. All right, we're back. So hopefully you figured out that your rhombus looks like this. So you know that your diagonals are 6 and 8. So half of that's going to be 3, the other half is going to be 4. And look, it's a 3, 4, 5 triangle. Woohoo! And so then I know each side length is 5, and so my perimeter is going to be 20 because 5 times 4 is 20. All right. Another time that we are going to have right triangles that we create is when we do something called droppingitude. This is an altitude. And so if you think about like when you're flying in a plane and they talk about like we're flying at an altitude of 30,000 feet, they're not talking about your distance like at a diagonal. They're talking about your distance straight down, right? So when we're talking about an altitude in a triangle, what that is the perpendicular line segment from the vertex angle in a triangle to the opposite side. So all we have done here is we've created a right triangle. And now altitudes can exist in any triangle. They don't have to look like that. This triangle, if I want to find my altitude, boom, there it is. So special things happen with altitudes in isosceles triangles and equilateral triangles, but we will talk about that later. All right, so moving on. Look, we've got a couple altitudes in this trapezoid. I want you to pause the video and try and find the area of the trapezoid. Okay, we're back. So hopefully you figured out that, I'm going to scroll down, that you could find the area a couple ways. So the first way is, no matter what, you have to find this height, right? The altitude, essentially. And so the way you do that is you do 5 squared plus the height squared equals 10 squared. So everything right over here. And you wind up getting that your height is 5 root 3. So you could, if you wanted to, find the area of this triangle, the area of this triangle, and then the area of this mama in the middle, and add them all up. Or you could remember that, you might know this, that the area of a trapezoid is going to be the average of the bases times the height. So 30 plus 20 divided by 2 times 5 root 3. Cool? All right. So one last problem, and I'm not even going to have you solve this. I want you to pause the video and think about how you would set up this problem in order to determine that side length. Okay, we're back. So you can drop a tude here. Watch. Now, granted, it's like an opposite tude, but it's still a tude because it's like going up instead of going down, but whatever. Look what you've just done. You've now created a little rectangle here with side lengths 8 and 7. And then you've got a nice little right triangle with side lengths 6, 8, and 10. It's a Pythagorean triple. It's a multiple of a 3, 4, 5. Cool? All right, so go ahead, tackle the worksheet, and I will see you soon. Thanks.